Communication systems are incredibly important in the modern world, so it should come as no surprise that they're going to be part of this course. Now, we're going to be looking into some fairly complex material that's going to build on your current knowledge of waves. We'll start off by looking at radio waves because that's going to give us a nice introduction and a nice way in to looking at modulation of waves, which we'll then build on as we look at some of the more modern things such as fiber optics and satellites. So we'll focus at the moment on radio waves and let's look at modulation. Actually, let's start off by thinking about what is a communication system. Now, the most simple method for communication typically is talking, face to face. It's low cost, efficient and quick. But it does have some downsides. The range is pretty poor. The rate of transfer is limited. There is a problem of crosstalk where two neighbouring conversations become mixed. And privacy and security are quite terrible. If someone wants to know your secrets, they just need to stand next to you. Now, if we use a microphone to convert the sound into an electrical signal, then transfer that as an electromagnetic wave, you'd think we could solve all these problems. But we can't. Not all of them. Although humans would not actually be able to hear the signals now, they would still have the same frequency as the voice has. The transmission would work fine, but crosstalk would be just as bad, which means only one person could communicate at a time. And this completely ruins it as a major communication method. Imagine if your phone always listened in to every conversation on every other phone. What we need is for every phone to have its own private communication line. Its own private carrier frequency to communicate on. And that's what happens. Depending where you are right now, there could be 5 or more phones in the room. Each phone is using its own private carrier frequency to communicate. Now, this carrier frequency is typically up to 2 GHz for 4G, over 6 GHz for 5G. But every phone is different, so these numbers are approximate. Notice that these frequencies are very high, much higher than the sound waves we can hear. So, we're not just turning our voice into an EM wave, we're combining the signal from our voice with this carrier wave in a process called modulation. Now, there are 2 ways to do this. Amplitude modulation, which is a lot like simply adding 2 waves in superposition, and frequency modulation, which is more complicated. Here's a demo of what amplitude modulation sounds like. I'm going to take a fairly high frequency sound wave. That is our carrier wave we can hear. And I'm going to modulate it with a 1 Hz signal. You should be able to hear that the volume, the amplitude of the carrier wave is changing with a frequency of 1 Hz. If I change the modulating signal wave to 2 Hz, the volume changes more rapidly. And that is amplitude modulation. The signal wave modulates the amplitude of the carrier wave. If I switch this around so the 1 Hz signal wave modulates the frequency of the carrier wave, we get this. The frequency is changed from low to high and back every second. That is frequency modulation. The signal wave modulates the frequency of the carrier wave. We'll look into both of these in more detail in another video, but that's basically what happens. There is a signal wave we want to get from one place to another. Your phone generates a high frequency carrier wave. The signal wave is used to modulate the carrier wave, and then this combined wave is transmitted, and at the other end the receiving phone demodulates the waves and plays the signal wave through a speaker. To do this, it has to have an electric circuit tuned to receive the carrier wave, filter out the carrier wave, and add gain to the signal. This has solved the crosstalk problem nicely. In the next couple of videos, we're going to look at these two methods in more detail, and then after that, we'll see what we can do about security and privacy.